Eldernauts, we're an international team with collaboration of University of Aalto in Finland. This is our team. It's composed by 3 mechanical engineering students and 1 art and design student. Well, the thing is, actually, right now the population is getting older. Actually, by 2050, the population over 60 years old is expected to grow up to 21.5%. With the growth of elder population, there's also a growth in the level of physical disabilities. But still, with life, we have to keep moving. So as a global community, we face a challenge, that is how to improve mobility in aging populations. When we began our research, we talked with Dr. Juan Carlos Molina, that is the chief of the Public Active Aging program. And he told us that the level of mobility that you have when you get older depends with the lifestyle you have your whole life. But there are some professions that they can't synchronize the requirements of their jobs with a healthy lifestyle. Like, for example, professional drivers. Professional drivers, in some cases, has to be in fixed position for almost 12 hours a day. They also have high levels of inactivity and experience high levels of mental load. Just in Chile, there are more than 1 million professional drivers. Some with this are almost 0.4 in Finland. After this, we realized more than 20 interviews to professional drivers here and in Finland. And with all this information, we developed 4 archetypes that help us to describe this population, also known as personas. With these personas, we hope to understand their situation better, to pose different scenarios of these users, and also define requirements for a posterior solution. We defined the experienced driver, the rookie, the independent, and stressed. And even though they were all really different, they have one thing in common. They experience uncomfortability in their day-to-day job. And going further, they experience the same associated risks, like circulatory problems, backbone damage, knee problems, muscle atrophy, and bone loss. So here we found our opportunity. That is to decrease the negative physical effects produced by extended driving hours.
In order to increase mobility during aging. One of the systems related with mobility is the skeletal muscle system. So let's see what's happened with this when you spend your whole day driving. At the beginning of the day, you start driving on a neutral posture. This means that your weight is well distributed around your column. Then, after a while, you consciously start to support your weight on your higher and lower back. And in long terms, this can damage your back muscles, making them to lose their main function, that is to support your column. This is called hypertrophy. Another damage that is discussed is bone, disc, and posterior damage. We looked the market and saw what was in the market. And the existing solutions mainly are for support. So the existing solutions are making the function that your back muscles should be doing. And they are not letting you develop your own support. So we keep researching, and we realize that doesn't seem right. The driver should be able to develop their own muscles. And one way to do it is to let them change their posture while they were driving. So we proposed to develop a device that creates postural changes that favors the transfer of load to appropriate zones of your body while you're driving. With all of this in mind, we explore different mechanisms. We start with a seesaw movement, that is one direction movement, a joystick movement, and an inflatable one similar to a Pilates ball. We took these prototypes to Álvaro Reyes, the director of kinesiology in this university, and he told us, first of all, there will be no negative biological effects with any of these mechanisms. The muscles will activate even if you're not conscious of the exercise. It's better if it has more degrees of freedom, and he suggested that we assess the mental load and the adaptation time. With all of that in mind, we decided to go with the inflatable one, because it was the one with more degrees of freedom. Then, right after this, we create our first prototype. This prototype was consisted in an air camera connected to an air compressor and covered in an elastic fabric. Then we took this prototype to the chief of laboratory of analysis of movement in this university, and he told us, first, The degrees of freedom of the device should be coordinated with the degrees of bending and rotation of the column. That he told us that he can evaluate the posture changes that we make with this device, and that to improve the effectiveness, we should work in time intervals. But at the end, the effectiveness, the real effectiveness of our device can only be evaluated by long-term studies. Then we took the same prototype to our users to evaluate the interface and sensations. We talked with 4 professional drivers and 4 non-professional drivers while they were driving, because this was the real situation of use. In interface, we realized that our piston, the thing that we are going to use to put the air inside the camera, should be able to should be adaptable to any kind of vehicle. The users told us that the control pad should be reachable by the left hand, and the user's weight should be coordinated with the inflation time. So we're going to need more air if the users weigh more. About sensations, we used a Likert scale from 1 to 7, and about comfort, they told us a 7 when it's not inflated. That is very comfortable, and goes to 5 after 5 minutes being seated in an inflatable seat. And about security, they told us a 7, and then goes to 6, which was great because we were really worried about the security of our users. With all of this and some other observations, we converge in our main requirements. First of all, our device is going to be powered by 12 volts input. Why? Because all the cars have a 12 volts output. The weight of the user should be coordinated with the inflation time. The control valve should be reachable by the left hand of the driver. To improve effectiveness, it should work in time intervals. And finally, and not less important, it should not increase the mental load that needs to be driving.
Well, and with all this investigation and the testing, we came out with Backhaul. That is a device that makes you unstabilized, so it can change your posture, activating your muscles, and decreasing the negative physical effects that comes with driving. So the installation is really simple. You install the device over the existing seat. You accommodate the piston or in the side or under the seat. You plug it into the 12 volt input. You put your weight and the level of activity you want to put, and you just turn it on. After this, the device will work autonomously all the day while you're driving. After you turn it on, the device inflates the camera and unstabilizes the music, the seat producing the exercise. It maintains like this 5 minutes. After this, it deflates, permitting the user to relax. This cycle repeats depending on the level of activity you put in the device, firstly. It contains 3 main parts. One is the air chamber, second, the piston, which is the one that inflates the camera, and also the control panel. First, the air chamber is made by urethane-coated nylon. This is made because it's leak resistant, and also it's really easy to manufacture. It has an oval shape, so it adapts to the hip bone structure, and also gives us the right amount of degrees of freedom that the device needs to work. The piston, it's designed in order to minimize the noises and therefore the mental load. It has a linear transmission system to do that, so it pushes the air to the air chamber. It has also a cylindrical shape that adapts to almost all the vehicles in the market. The control panel has an on-off button that is always reachable by your left hand if needed, and also has a level of intensity knob that you can so you can develop your muscles through time. And it also has a user's weight knob, so the amount of air in the chamber is always optimal for the user. Well, with all of this, we want to develop a device that allows you to stay healthy while you can do your job the best way possible. So what we're waiting for? Thank you.